All right, welcome to video number 54. We're going to talk about how heat is transferred in the earth. So summary time at the beginning, I want you to be able to define heat transfer, and I want you to be able to describe and diagram the three different ways that heat is transferred. So it's actually the transfer of energy that always travels from hot to
cold.
There you go. There are three ways. You want to read the three ways?
Sure. Conduction, convection, and radiation. And one of them I can never keep straight because the years that I've explained this, one of them always seems like the other one. Don't ask me which one it is. I think it's radiation is like similar to something else.
Yeah, we'll talk about that. We're going to go through each one. So let's start with conduction. You want to do that one first?
Sure. Okay. Conduction. It's point to point, which means that it has to be in direct contact. Now we're heat exchange there. Transfer of energy from hot to cold. It must have contact or touch.
Right.
Here's your example of your egg. So how come you have a conduction stove if you can heat over a stove like that, and that's considered conduction?
I think you're thinking of induction.
Oh, I am.
Yes. Induction means it won't turn on until you actually put the pan on it. Conduction means it'll always turn on no matter what. All right, so convection, I'll do this and then you want to do the next one?
Sure.
Okay, so convection, actually you need a liquid or a gas to do it, and what happens is you need either a fan or you need something to push either that air or that liquid, and I think a good one is my big bathtub, right? Put on the big jets and that hot water circles around and around and around. That's what convection is. It keeps those currents going, and you always need something that's going to move it from place A to place B. So you've got your boiling water up here, right? So you have your heat down there, but when the water heats up, where does it go? Well, it rises to the top, and then it gets nice and cool, and it sinks back down. And that's exactly the same thing that happens in your house when you get heat, right? Which we need right now.
And that's why wing chairs actually are invented, was because of this rotation that goes around like this. Is the wing chairs, the high backs and the edges.
Yeah.
You would sit in front of a fireplace. And so imagine that the fireplace was, I don't know if you guys can see this, but it was right there in front of the radiator. You can see where the arrow goes. So you'd be sitting in a chair, and the cool air would come and hit you in the back. So that's why you have wing chairs in front of a fireplace, was to keep that cold air from hitting you in the back.
I didn't know that. So cool.
When you're remembering convection, remember Mrs. Whitney's silly story about wingback chairs.
Oh, cool. All right, radiation, all you.
Okay, radiation is heat energy is transferred without some intervening medium.
Now, wait, are you talking about that radiation that's going to melt my face off, or that I get if I have cancer, I get radiation?
No, that's a different kind of radiation.
All right, just checking.
You see, there's no hazmat things in there. Radiation needs nothing, no direct contact, no gas or liquid. An example is sunshine or a fireplace, and so fuses make.
So this one you don't actually need anything, so you don't have to touch it, right? You're not going to touch the sun, and you don't need liquid or gas. It just means when you walk out into the sun, you know how you feel warmer? That's radiation. It just means you didn't need anything to intervene for you to feel warm. Okay. So you didn't need that liquid, you didn't need that gas blowing around, and you didn't have to touch the sun to feel warm.
There you go. Thanks. Heat moves around the universe in three ways. So let's take a look at the part of the universe we call the kitchen. These pancakes are touching this hot griddle. So heat can go directly from the griddle into the liquid pancake batter fast enough to turn the batter into a dry pancake. Here we have fruit cooking over boiling water. The steam cooks the fruit all the way through. This fruit is doggone good on pancakes, and the steam makes it hot, hot, hot. This is called convection of heat. Here we have a flame, and we'll roast some marshmallows. The flame cooks the marshmallows without anything touching anything. This is called radiation. So those are the three ways that heat moves around the universe. Conduction, conduction of heat. Convection, convection. And radiation, radiation. Not bad. Marshmallow fruit pancake order up.
Oh, Miss Whitney, you want to run down just a quick review of what we just talked about? Good summary?
So conduction is the energy is transferred by direct contact. So you have to have something in contact with something else for it to be able to get the heat from the hot to cold. Okay.
Hot to cold.
Convection is energy that's transferred by the mass motion of molecules. In other words, you have to have some sort of liquid in the case of the pot, or some sort of air is in the case of like the weather.
Yeah.
And
motion, keyword there. Motion. Yes.
Okay. And radiation energy is transferred by electromagnetic radiation.
Which is another way to say you don't need anything to feel it. You just have to be next to it.
So that's the one you could have in a vacuum.
Yep, absolutely. Okay.